How do you diagnose windmill pitching mechanical flaws in softball? Imagine watching a pitcher wind up and wondering if every move is helping or hurting her performance. Spotting mechanical flaws in windmill pitching can make a big difference in how well a player throws and stays healthy. To do this, you need to carefully observe each part of the pitch from start to finish. First, look at the wind-up phase. Check if the pitcher shifts her weight properly. A common mistake is leaning downward instead of hinging back at the hips. This reduces her forward drive and shortens her stride. Also, see if her trunk stays roughly parallel to her tibia. If she leans too far forward or back, it can throw off her balance. At the end of this phase, her hips and shoulders should be mostly square to the plate to generate maximum force. Moving into the stride phase, watch for the length of her step and where her foot lands. An improper stride can disrupt her energy transfer and cause her to lose balance. During the acceleration phase, focus on her arm path. Her throwing arm should lift fully around the 12 o'clock position with her shoulder stable. This allows her to transfer energy smoothly from her body to the ball. In the follow-through, look for controlled deceleration and a balanced finish. If she is jerky or imbalanced, it could lead to injury or reduced speed. Now, check her body alignment. Her hips and shoulders should stay neutral in the frontal plane. Excessive arm abduction or external rotation of her drive foot might indicate flaws. Also, observe her trunk's position in the sagittal plane. Too much flexion or extension can throw off her mechanics. The lower body is key. Weakness or limited external rotation in the drive hip can reduce her power and increase injury risk. She should hinge at the hips properly instead of bending her knees too much during weight shift. Next, analyze how energy moves through her body. A smooth, well-timed transfer from her legs through her hips and trunk to her arm shows good mechanics. Faulty sequencing often causes her to compensate, which puts stress on her shoulder and elbow. Using tools like slow-motion video helps catch subtle errors. Watching from multiple angles makes it easier to see flaws in her form. Physical assessments of her hip mobility, strength, and trunk stability can also reveal physical limitations that affect her pitching. Common flaws include a downward weight shift instead of a proper hip hinge, excessive trunk flexion or extension, poor alignment of hips and shoulders, improper stride length, weak external rotation, and poor sequencing of body segments. She might also drop her arm too early or have instability in her shoulder during arm elevation. Coaches and trainers should use video reviews and physical tests to identify these issues. Once flaws are spotted, targeted drills, strength exercises, and flexibility work can help correct them. This approach ensures she can pitch effectively while reducing her chance of injury. Remember, windmill pitching is a full-body movement. Strengthening the hips and core and maintaining proper timing are essential for safe, powerful throws.